I'm Mike Walsh, CEO of EspriGas. Our products, industrial, beverage, and medical gases, are used in all kinds of applications. This training session is designed to teach you about the products we sell and the safety hazards related to them. I want to thank you for taking the time to learn, because above all else, we want to keep you safe. Thank you.
Hello, and thank you for taking the time to view this TMG safety presentation. We will cover a variety of topics separated into modules. We will begin with basic oxygen and nitrogen safety rules. Next, we will cover the different types of gas packaging, as well as how to identify cylinders. We will conclude with training on the appropriate storage and handling of gas. Module 1, Oxygen and Nitrogen Facts and Safety Tips. Oxygen. As you're probably aware, oxygen is found in the air we breathe. It makes up approximately 21% of the air around us and is one of the most common elements on Earth. There are a number of industrial and medical applications for oxygen. Industrial clients use oxygen to rapidly support combustion in applications like cutting metal, melting steel, and welding. In healthcare, the major application for oxygen is to sustain breathing when patients are ill or incapacitated. Nitrogen is colorless, tasteless, and has no smell under normal conditions. What may surprise you is that while nitrogen actually makes up the majority of the air we breathe, around 78%, it can be deadly if consumed alone. Like oxygen, nitrogen has both industrial and medical applications. Nitrogen doesn't react with other products at temperatures below 266 degrees Fahrenheit, so it's often used to prevent other products from reacting with materials. For instance, it's used in the chemical industry to blanket volatile products from reacting with oxygen. And in the healthcare field, researchers use nitrogen to freeze living cells so they can continue to study the specimens. Now that we know a little bit about oxygen and nitrogen as molecules, let's discuss some of their safety hazards. Oxygen is a key ingredient in the combustion of fire and can be very dangerous if it's not handled properly. When storing or handling oxygen, always remember the 3 elements of the death triangle: ignition source, oxygen, and fuel. To reduce the risk of fire, always remember to remove one of these elements. If a fire does occur, there are 3 ways to extinguish it in an emergency. You can remove the fuel source, take out the oxygen by smothering the fire, or you can remove the ignition source, the heat, by absorbing it with water. Due to its colorless, odorless qualities in gas form, nitrogen has been given the nickname the silent killer. In an enclosed space, high levels of nitrogen will deplete oxygen and asphyxiate living creatures. Liquid nitrogen is extremely cold and dangerous to the touch. In this module, we'll review the different types of gas packaging. Medical gases can be stored in one of 3 ways: high-pressure cylinders, liquid dewars, and large bulk reservoirs. High-pressure cylinders are commonly used in medical facilities, such as dental offices, vet clinics, surgery centers, and nursing homes. Liquid dewars are common in rehab facilities, where patients may need higher levels of medical oxygen, as well as increased mobility. Portable liquid dewars are often used by patients while completing their rehabilitation routines for their duration and portability. And on the other end of the scale, bulk tanks are used in cases where a large backup supply of medical gas is required to be kept. For example, hospitals are required by the National Fire Protection Association to maintain a backup gas supply equal to the daily use of the entire facility. The next module covers how to identify cylinders. You can identify cylinders in 4 different ways: by their color, labeling, fittings, and markings. Cylinders can be color-coded to identify their contents. For example, green for oxygen. Sometimes only the tops of cylinders are color-coded. Sometimes it's the entire cylinder. There is a standard approach to color coding, but you should always double-check that the cylinder contains the gas you expect by checking the label affixed to the cylinder. Medical oxygen and medical air are 2 of the most commonly used high-pressure cylinders. Notice the green and yellow, noting their contents. As well as identifying the gas contained in cylinders, labels show the gas's chemical symbol, the purity of the gas, its volume in liters at a specific temperature, and other information. The label will also list specific hazards and give extra safety precautions, as well as instructions in case of exposure. We recommend adding an additional tag to the label that can be used to identify how much gas remains in the cylinder. The gas label has 3 statuses: full, in service, and empty. If the full tag is still on the label, then the cylinder has not been opened yet and is at max capacity for gas. Once the cylinder has been opened, it's no longer considered full, and the full label selection should be removed. Cylinders should always be separated and stored according to these statuses to avoid very dangerous situations. For example, if during an emergency a nurse needed a full or in-service oxygen tank and an empty one was mislabeled or in the wrong place, a patient could be put at serious risk. You can also identify different cylinders by their different fittings. There are 3 different types of valves: post, threaded, and integrated. Cylinders for different gases are fitted with different valve types to prevent the interchange of regulating equipment between gases that are not compatible. The final way to identify a cylinder is with its markings on the cylinder shoulder. There are some standard markings you will see on gas cylinders shown in this illustration. As well as the markings shown here, you might also see an asterisk after the test date, indicating the cylinder may go 10 years before being tested again, or a plus sign that indicates the cylinder is approved for filling to 10% above surface pressure. The next modules cover the proper ways to store and handle gas across all packaging methods. There are 6 primary rules for storing gas cylinders. Always post the name of the gases stored on the outside of their storage area. The storage area should be fire resistant. Make sure you keep full and empty cylinders separate. Never store cylinders close to flammable substances such as gasoline, grease, or petroleum products. Do not store flammable gases together with oxygen. Protect cylinders from damage by ensuring their caps are kept on, and by making sure only trained, authorized users handle the cylinders. It's also very important that only experienced, trained professionals use cylinders. They should also verify the cylinder contents before opening. Again, ensure the cap is kept on a cylinder until you are ready to use it, and protect cylinders from falling. You should always crack the cylinder prior to attaching a regulator, and ensure you use the correct regulator or reducing valve. Open valves slowly and never use a hammer, wrench, or Vaseline to force a valve open. Do not force any threaded connections, and keep all connections tight to prevent leakage. Before removing a regulator, turn off the valve and bleed the pressure. When moving cylinders, always make sure the protective valve cap is on. Never lift a cylinder by the cap. It can be very dangerous if cylinders are hit, so be sure to avoid dropping them or letting 2 cylinders hit each other. Never drag, slide, or roll a cylinder. Instead, use a cart to transport them. This visual illustrates a right and a wrong way of moving a gas cylinder. There are 4 primary rules for storing liquid dewars. Ensure proper ventilation where dewars are stored or used to reduce the risk of fire, explosion, or asphyxiation. Do not store liquid oxygen containers on wood, asphalt, or oil-soaked gravel. When saturated with liquid oxygen, these materials can explode after even a very slight impact. Instead, use concrete or clean gravel under storage areas. Do not store containers where they may come into contact with moisture. Keep dewar flasks covered with a loose-fitting cap. Never accept delivery of defective containers. Make sure to always wear appropriate safety gear when handling liquid dewars. Leather gloves, eye protection, and long-sleeve shirts and pants. If the neck of a dewar flask is blocked by ice or frozen air, follow the manufacturer's instructions for removing the blockage. Make sure never to touch any leaked liquid nitrogen or liquid oxygen. The storage and handling of bulk reservoirs. Bulk reservoirs are used to supply large amounts of medical gas to a hospital or other institution where a large supply of medical gas is required to be kept. Bulk reservoir systems typically contain 2 parts. 1. The bulk reservoir itself, and 2. The backup gas supply. This emergency backup system is usually met by a cylinder manifold system or another bulk reservoir. The National Fire Protection Association, NFPA, requires facilities using the gas for patient care to maintain a backup gas supply equal to the daily use of the entire facility. When a bulk cylinder is first installed, there are specific regulations as to its location. For example, a bulk cylinder needs to be installed away from wood-framed structures, door openings and windows, sidewalks, vehicles, and non-ambulatory patients. The NFPA defines a bulk oxygen system as more than 20,000 cubic feet of oxygen. Some of the major components of the bulk system are the insulated reservoir, the pressure-reducing valve, and the pressure release valve. Once installed, the key components of a bulk system must be maintained at certain levels. In the event that a bulk system is not functioning properly, a cylinder manifold system may be used as backup. In a cylinder manifold system, gas cylinders are banked together in a series with a primary bank that is actively being used and a reserve bank to be used when the primary bank is depleted. Pressure is often used to determine whether or not the primary and reserve banks are reaching low levels. When pressure decreases to a certain point within the primary bank, the supply alternates to the reserve bank. Cylinder manifold systems are often called alternating supply systems because the primary and reserve banks alternate based on their levels of supply. Within the cylinder manifold system, low-pressure alarms are used to indicate when one side of the cylinder bank is low. At this point, the system is switched to the other side, and the low cylinders should be replaced to become the reserve bank. In a typical bulk cylinder facility, an extensive piping system feeds gas into all floors of the hospital or facility from the bulk reservoir or cylinder manifold system. Each floor will have its piping system and control valves to manage the gas flow on their specific floor or outlet. You can see here how zone valves might be distributed on each floor. It's vital to know where the shutoff valve on your floor is located in case of an emergency. The image shown here represents what a zone shutoff valve looks like in a typical facility. A zone valve must never be located in a room with station outlets and inlets that it controls, so that the valve can be used in the event of a fire without placing the operator in harm's way. The station outlets provide connections for gas delivery devices such as flow meters and mechanical ventilators. They also contain check valves that open when a delivery device's flow meter adapter is inserted into it. Station outlets are located on each floor of a typical facility. In your facility, the high-pressure bulk oxygen supply is reduced to 50 psi working pressure in the patient's room, where it can be used to operate respiratory equipment. At the station outlets, you can use the Diameter Index Safety System, DIS, DISS, threaded fittings to connect any gas-powered devices to the station outlets. These fittings are marked differently from one another to ensure that the correct fitting is used for the correct gas type to prevent cross-contamination or serious injury. Along with these safe measures, you should follow some simple do's and don'ts for bulk oxygen storage and handling. Ensure you remove one of the 3 elements of the death triangle, usually the ignition source. Know the location of the emergency shutoff valve in each zone. Ensure that oxygen is flowing from the outlet before any patient use. Do not store flammable material near oxygen. And do not use a wall outlet that's leaking. Do not smoke near oxygen. That concludes our training. As a review, you have learned the basics of oxygen and nitrogen safety, the different types of gas packaging, cylinders, liquid dewars, and bulk, how to identify cylinders by their labeling, color, fittings, and markings, and how to store and handle gases safely. If you have any questions about the material covered in this video, please do not hesitate to contact us.